Hello everyone, in rotational dynamics we'll be doing kinetic energy, torque, work plus power in this video. So let's start off with kinetic energy. Let's say there are n number of particles with, from axis of rotation y dash with radius r1 with the particle m1, r2, m2 and so on with mass mn. So here the kinetic energy of the first particle will be 1 by 2 mv square. So here in terms of rotational dynamics we can write v equals to omega r. So this is omega r whole square becomes 1 by 2 omega square mr square. So here mr square, sorry, m1 r1 square with linear velocity v1. And in this case the angular velocity always remains constant for whichever particle it is, but the linear velocity is different for different particles. So here kinetic energy of the second particle is 1 by 2 omega square m2r2 square and so on for n number of particles rn square. Now here the total kinetic energy is the sum of all the kinetic energy of the body is the total kinetic energy or the sum of the kinetic energy of individual particles, which is k1 plus k2, sorry, ke2 plus so on ken, which is, let's just take 1 by 2 omega square common. We get m1 r1 square plus m2 r2 square plus mn rn square. And we know this is just our moment of inertia as I. So let's write it nicely. Let's write it over here. So we get our expression that kinetic energy is equals to 1 by 2 I omega square. So this is our required expression. Now for torque. Now we have something very similar to that. But first we need to know that torque is equals to the force into the perpendicular radius from the axis of rotation. So basically the tau 1 or the torque of the first particle is, force 1 into radius 1. We can write force as mass into acceleration 1, since each also has different accelerations, but all of the particles have the same angular acceleration ma1 r1, which we can write as m alpha 1 r1 r1, because acceleration is alpha 1 into r, just like how v is equals to angular velocity into radius, acceleration is also angular acceleration into radius. So this becomes mr1 square into alpha 1 and so on, and the similar for the second particle. Sorry, this should be just alpha, and so on for n number of particles, mn rn square alpha. And here again the total tau is equals to tau 1 plus tau 2 plus tau n, which I'll take it as m1 r1 square plus m2 r2 square plus mn rn square into alpha, which here we get tau equals to I alpha, which is our required expression. Now for the work done. For here our syllabus requires us to find the work done for a couple. So a couple is two forces that are equal in opposite, that act on different lines of action. So here a couple could be a force here while a force down here. So let's say for a circular body like this, O, we have a body at A here, B here, and let's say a force acts on it such that it displaces the body to A dash through angle theta. Now this is due to couple, so this is force, and that means another force, the same force equal in magnitude x here, displaces it with the same angle of theta to B dash. Now here we know that the work done is the sum of the works done, so which is force into displacement, so force into AA arc plus force into BB arc. Now here we have the arc formula that S equals to R theta. Here S is just an arc. So here if this is radius R, then work is equals to FR theta plus FR theta, giving us work equals to F 2R theta. Now why have we done 2R? Well, here from this we will get F into 2R into theta, so we will get tau theta. Now you will say, how will you get tau? Because as tau's definition, we have force into the perpendicular radius, and here the perpendicular radius from one force to another is, well, 2R, which is R plus R, which is 2R. So that gives W equals to tau theta. Now for power, it's just dW by dt, which is tau theta d by dt. Tau is constant, goes outside, by dt, which gives us power equals to tau omega. This is required for rotation dynamics. I'll be doing angular velocity and conservation of angular momentum in the next video. Thank you. Not angular velocity.